Hi everyone, welcome to this product council session. This is a slightly different session from what we're used to. The intention behind this is to start looking at long-term strategy for Mojaloop. So while this session itself isn't defining that strategy, the aim of this session is to look at some of the influences outside those that we would normally consider and try and see how that might influence the Mojaloop roadmap in the future. So to that end, I was talking to Yevhen, who was going to present today, a couple of weeks ago now, about the work that he's been doing in Ukraine outside his work with Mojaloop. And I thought it was, to me, absolutely fascinating. And I hope that you will find it fascinating as well. He's going to be talking about his work in developing robust, reliable infrastructure for small and medium DFSPs. And I think there are lessons here for everyone involved in the development of robust financial services infrastructure. So with that, I will hand over to Yev, and I hope we'll have a robust Q&A section at the end as well. So thanks everyone, and over to you, Yev.
Yeah, thanks, Paul. Yeah, so I'll go ahead and share my screen now.
Yeah. Hey, got it.
Hope you can see it.
Yes. Yes, is there.
Great. Yeah, so everyone again, and thank you for the opportunity to present today. For those who don't know me yet, my name is Yevhen. I've been building technical solutions for complex environments for over 15 years. I'm a software engineer at Mojaloop, and I'm also one of the co-founders of Skynex, a company that builds secure infrastructure for difficult environments. So what I want to share today is not just a product, it's the platform that originally built for infrastructure limited environments. It happens to align closely with many of the barriers we still see in DFSPs, like during the onboarding process, like the lack of DevOps, lack of power, lack of internet, and limited options for secure self-hosting, basically. So, because enabling small DFSPs is part of the Mojaloop's mission, this platform could help make that participation more practical and more sustainable. So in this presentation, we'll look at the challenge why small DFSPs still struggle with infrastructure. Then I'll walk you through the platform, what it is, how it works, and what it can do. And finally, we'll look at how it could support DFSP's onboarding and align with Mojaloop's long-term strategy. So, okay. So one of the most persistent challenges in expanding Mojaloop participation is infrastructure, especially for smaller DFSPs. And many of these providers don't have dedicated IT or DevOps team. They also operate in regions where internet or power isn't stable, which makes even cloud-based systems hard to rely on. In some cases, cloud is simply out of reach due to connectivity cost or regulation. And while some DFSPs might experiment with low-cost DIY setups like Raspberry Pi kits, those often fail to meet reliability, availability, and the SLA expectations of a Mojaloop integrated scheme. On another end, enterprise-grade deployments may be robust, but they are also expensive. They're kind of hard to maintain, and they assume a presence of on-site technical staff. So that leaves many DFSPs stuck between two options. One is affordable but fragile, and one that's reliable but out of reach. So as a result, Mojaloop onboarding slows down, becomes inconsistent, or stalls entirely, not because of the stack itself, but because of the hosting environment isn't viable. So the question is, how can we support small DFSPs with the more reliable, more secure, and manageable infrastructure path? So let's take a step back and imagine what DFSP onboarding could look like. So what if connecting a DFSP to Mojaloop was as simple as activating a SIM card? Imagine like a small device arrives on site, someone plugs it in, and that's it. Like no setup, no command line interface, no infrastructure teams. So if something breaks, you don't troubleshoot it, you just swap it, and everything else from updates to monitoring is handled remotely. So this kind of onboarding experience could remove the barrier for small DFSPs, especially in regions without local IT or reliable internet. So you don't deal with fragile DIY kits, like no complex file provisioning, just a secure pre-configured system that runs from day one and stays up to date. And when we think about scaling Mojaloop participation means making onboarding this simple. And in the next slide, I'll show you the platform that's already delivering that experience today. So the platform called Skynex Edge Platform, it's designed for environments where infrastructure can't be taken for granted. It's a plug-and-play microcloud that's built specially for environments like those many DFSPs operate in, where infrastructure, power, and network reliability are constrained. So each unit arrives already pre-configured with all necessary software. There is no setup, no needed on-site, technicals or DevOps support. So the hardware is compact, it's fanless, and it's built to run fully offline, where you can run it from the uninterruptible power supply. From the outside, it behaves like an appliance. You plug it in and it works. Security is also built in at every layer. It has secure boots, encrypted data everywhere, like at the rest and in transit. Supports signed workloads and remote monitoring. So the pricing is straightforward, the flat monthly fee that includes hardware updates and full lifecycle support. So this model has already been deployed in production in Ukraine across sectors like healthcare, retail, and telco, and has proven its resiliency through blackouts, poor connectivity, and a lack of IT support. And yeah, so it's fully compatible with the Mojaloop workloads like adapters, PM4ML, and onboarding flows. So all of these brings to life something the Mojaloop community has talked about. It's like a true Mojaloop in a box built for realities DFSPs actually face. Yeah, so let me walk through the experience that's like what it looks like in practice. So from the local operator's point of view, it's like really simple. The hardware arrives already configured. They plug it in and it runs. If the device ever fails, whether it's detected remotely or reported locally, replacement is shipped. So the courier drops off the new unit and collects the old one. So using local fulfillment centers, delivery usually takes about a couple of days, like 1 to 3 days, even in rural areas. So the operator in the just plugs in the new unit and the operation resumes automatically. No reset, no manual reconfiguration is required. So this swap-based model by it's like the model that operates the whole the whole environment. The old unit is removed, the new one takes over, and no technical recovery is required. So everything else, updates, monitoring, troubleshooting is handled remotely. Under the hood, it's still secure. The device is claimed with the QR code or Bluetooth, and it generates its own cryptography keys, which never leave the device. Then it receives the configuration and the workload. And even during
Can I interrupt you there? Yeah.
Yep.
What do you mean by the device is claimed securely? Could you expand on that a little?
Yeah, so basically, technician can use his smartphone, like the app, so device has a Bluetooth inside, and using the phone application on the phone can connect to this device, and application, you can log in into the application, basically in your account where your subscription is activated already, and application will connect to the device with a Bluetooth, and having your subscription on the device on this application already activated means the device is claimed like this. So basically, it's the proof of proximity that you are the one that ordered the device, you are the one that ordered the subscription, and it prevents anyone from using the device like in any steps during the transit.
Yeah. So
So
this
yeah,
is assuming that there is a person who has an app, which
well,
effectively
it can
it must be a
be
mobile banking app of some form.
it has different activation options. Like the Bluetooth is just the simplest one. Another can be a QR code, so you can have a camera, or you can just log into the portal and just type the code from the device sticker. So it's like at least 3 options already
Yeah.
supported. So if you don't have a camera on your device, or you don't want to install anything on your phone, I mean, you can still activate. So it's still secure. Um, yeah. Does it answer your question?
Yeah, I just wonder where the app comes from. That's
Yeah,
all.
like it's
Uh,
it's uh, it's part of the platform actually. So
Okay,
yeah,
fine. Yeah.
yeah.
Okay. Thank you.
So yeah, so also want to say that like during the internet outages, the device continues to operate using the local state. All this cluster on the platform continues operating with the local state, and when internet is recovered, everything is synced back online. So this entire approach removes one of the biggest blockers for DFSPs onboarding. It's infrastructure complexity. So one important technical point is every deployment includes at least 2 nodes, even in the smallest setups. So those nodes operate in active modes. It means if one goes down, the others continues running without interruption. There is no manual failover, no reboot, like no reconfiguration. It's completely seamless. When a failed unit is swapped, the remaining node keeps services online during the replacement process. And this kind of built-in redundancy is part of the default design. It's particularly well suited for smaller DFSPs that need to meet scheme SLAs but don't have a local AT support. And at the Mojaloop level, it helps ensure consistency uptime across participants, like reducing the risks of retries, orphan transactions, or support escalations. Yeah, so let's talk briefly about security because it's critical for any infrastructure, especially in financial environments. So this platform uses a secure boot process. So it means only signed and verified software can run on the device. keys are generated on the device during the onboarding and never leave the device. Like this includes setup, operation, and even during the device swap. Like keys are not exposed at all. All the data is encrypted at rest and in transit. The container images are signed and verified before execution, so no one can inject or run untrusted software by mistake. The system also follows the zero trust communication model. It means every communication is encrypted and authenticated. And if tampering is detected, the device locks itself down to protect keys and workload integrity. So all this means, and all these mechanisms means that the system operates securely, and it's actually kind of aligned with Mojaloop expectations, what scheme expect Mojaloop participants to be, like around the compliance, auditability, and participant trust. And for DFSPs without dedicated security teams, this level of protection could help meet scheme level security requirements, but with the far less operational overhead.
So, sorry,
Yep.
is there some form of security module for storage within the
Yeah. So
device?
regarding security module, it has the keys fused into the device itself. So they are not readable by anyone, like even root. So it replaces the kind of HSM modules you would expect from the
Yeah.
systems. And also HSMs usually are not practical when you have multiple nodes because each generates its own keys usually. So, I mean, in offline and decentralized systems, they are not just practical. So you can have one HSM model and one node, but it's not reliable because it doesn't have high availability in that sense. Having two nodes means each one should have HSM module, which creates multiple keys, and it contradicts with how Mojaloop usually operates, like with the keys, right? How transactions are signed, etc. So the module included in the security design is that keys generated on the device stay on the device, are not readable by anyone, and they support the key storage enclave that stores basically the user keys, right? So during the boot, if everything goes fine, if no tampering is detected, if the system has signed images, only in this case, keys are from this enclave, from the secure storage, are encrypted and provided to the workloads, but only like injected to the workloads, not like exposed to anyone like that wants to read them.
Okay, thank you.
Yeah. Yeah. So just a brief high-level overview of the platform architecture. At the top is the cloud control plane. It manages workloads using GitOps, meaning all configuration is version controlled, audited, and delivered automatically. It also includes CI/CD pipeline for building Docker images and performing vulnerability checks. So workloads are delivered as signed images and pulled from a verified registry. The edge device receives updates and configuration with encrypted channel. So each edge unit runs a hardened OS and a firmware layer with secure boots, local key storage, as I mentioned, and the tamper detection mechanisms. And on top of that sits a Docker compatible runtime for workloads. Also, the networking layer includes a built-in gateway that supports OIDC integration with local or external identity providers, and the JWT-aware routing, including optional firewalling for service-to-service control. Secrets can be managed using integrated tools like SOAPs or Vault, depending on deployment model. And finally, there is a lightweight observability stack based on Prometheus and so Loki and optimized for resource-constrained environments. So this architecture is well suited to support running DFSP integrations, security like in secure fashion. So this is just an example of what a small deployment might look like in practice. It has two-node cluster where each unit has 4 ARM CPU cores, between 2 and 8 gigs of RAM, and local storage ranging from 16 to 200 up to like more than 200 gigs of eMMC storage. The system runs fully offline when needed. It supports remote management, updates, and monitoring, all without on-site technician. Power consumption is very low, which means the entire cluster can run for hours on a small uninterruptible power supply. It's really useful in locations with unstable electricity. And this kind of configuration has already been tested in real deployments in other sectors. And it has remained operation during blackouts, poor network conditions, and absence of any IT support. So in those deployments, the total cost, including hardware, has ranged between $15 and $25 per month. And while this is just a reference point, like the prices, but similar model can be viable in other countries, especially where local fulfillment is possible. And so the architecture is also designed to scale, not just in size, but in operational consistency. So at the low end, two-node deployment might serve as a single branch, mobile kiosk, or a small DFSP. Each node includes a few CPU cores, small flash storage, and enough memory to support Mojaloop components and local processing. And for larger needs, the same model can scale up to more RAM, more storage, higher speed networking. And this could be relevant for regional DFSP hubs, larger institutions, or aggregator handling multiple tenants, for example. So the important part here is that nothing changes in terms of how it's managed. Whether it's 2 nodes or 20, it's still zero touch, still remotely configured, and still autonomous at the edge. And that consistency is what makes the platform well suited for distributed multi-participant Mojaloop environments, even if the DFSPs themselves vary in sizes and technical capacity. So this is the diagram that shows how onboarding and lifecycle could work in secure, repeatable way. It's not just for a single DFSP, but across many type of participants. So each role is clearly defined. There is a central IT or integrators that prepare the adapter images and templates for integration with the core banking systems. The DFSP registers itself through the scheme, and the device is shipped pre-configured. So when the new unit arrives, a local operator like a branch manager or agent claims it, as we discussed, with scanning a QR code or pairing with a Bluetooth. It doesn't require technical knowledge at all or a field technician. So once claimed, the device generates its own keys and joins the trust model. So the core banking, mapping profiles, and configurations can be delivered remotely. So yeah, just scroll a bit more. Yeah, so after that, the scheme receives public keys and metadata and completes the binding process. And from that point, the device is autonomous. It receives updates, streams telemetry, and can be replaced using swap-based recovery. And this model has already been tested in other sectors, but it aligns well with how Mojaloop, vision, like aligns well with Mojaloop vision basically, and for scalable and low friction DFSP onboarding. It also complements tools like MCM and PM4ML and could help schemes reduce support overhead while maintaining trust and compliance.
Okay, so in the context of that diagram, the local
Yeah,
operator is the scheme operator, is that correct? Or the hub operator or whatever it might be. Is that
this is the hub basically, but
yeah,
can be yeah.
yeah,
This is basically
and
our MCM,
yeah,
and actually the whole integration, uh, like it only will require just a few API calls to
yeah,
the Linux control plane to
yeah.
initiate all this process.
I'm just trying to clarify the difference in the role between DFSP and local operator.
Yeah,
That's
so local operator is basically the branch. So
right. So operating in support of the scheme,
yeah,
effectively.
I mean this is the basically the person or the representative that supports the DFSP branch on site.
Okay, okay.
Yeah. So as you can see, there is not much. Uh,
Not much for them to do. No.
yeah, yeah. Oh, sorry,
Yeah,
sorry. Local operator. Yeah, this one is DFSP.
yeah,
Just
yeah. So the local operator is responsible for activating the device.
yes, yes. So DFSP, I mean, this is just an office basically.
Yeah,
An official representative. Local operator is the kind of non-official person, probably, mm, I don't know, not a technician, but that can just plug anything, just some guy walking around and can just, uh, check stuff around.
yeah.
Yeah,
Okay. Thank you.
yeah, sure. So, yeah, just
Maybe a question. This is Benjamin. Why wouldn't we want to look at the DFSP as an entity itself rather than having the local operator?
uh, yeah,
I
so
mean, I'm struggling to find what's the use of that local operator, because if you look at it, you could also look at it as an entity on its own, the DFSP itself.
yeah, I mean, DFSP, let me know if you understand correctly. So DFSP in here represents the DFSP branch, basically. So one of the local or rural DFSP branches of a DFSP. And I mean, it operated under
The point is, we are
yeah.
looking at it as a do it yourself. And I can understand the bit of the centralized IT integration and everything. Just to build on what Paul was asking, this local operator kind of like explanation is not coming out very clearly. What is it in the sequence and what specific role does it kind of like play? That's what I was asking. Is that a little bit clearer?
Yeah, so local operator can think about it like the DFSP itself. It's just like another person. So it's not the same person that might register or do this first registration steps, like submitting registration information, doing some legal paperwork. So this is only DFSP job in this participant.
Yeah, does the local operator work for the DFSP?
Yes.
Okay, so then a staff member of the DFSP.
Yeah, it's just a staff member basically. Yes, yes.
Okay, yeah.
Anyone from the staff member basically.
Right, that's much clearer. Thank you.
Yeah, yeah. Sorry. Yeah, so this is part of the DFSP. Yeah, sorry for not being that clear.
Yeah, yeah.
Yeah. So, yeah. So from this diagram, like this one and this one, they are sitting basically at the same office.
Right.
So this guy initiates the registration by itself. So after illegal work is started, the technical point of onboarding, the technical side of onboarding can run in parallel while the KYC is processing another legal paperwork is prepared. So this process can run in parallel. So upon registration on MCM and when the scheme approves the DFSP for being onboarded, for being connected, just a simple approve code can be sent to the basically to this control plane, and starting from this point, everything is handled by the platform itself. So the allocation of hardware, the shipping of the devices, and then somebody from DFSP, like on DFSP side, just claims that the device actually arrives at on site, and just using the Bluetooth or QR. Then this integrator, which can adopt or distribute core banking system adapters, can just update, tweak, or provide the adapters for a particular core banking system. So the DFSP, they can just select from predefined templates basically, right? So no need for this complex API development. So everything can be backed into the device already. So yeah, all these the cryptography keys. Yeah, so basically the control plane here acts also as the authority between the DFSP and the scheme to exchange the public keys and metadata, so that the control plane knows that devices are securely arrived on site, that they are claimed securely, and after that, device can send all the metadata, the public keys, to the control plane, and this metadata is shared with the MCM. So right after that, the MCM can bind the DFSP credentials, like the TLS public keys and other secrets, to the participants list they maintain. And yeah, so life cycle continues after that, and managed if something fails, a replacement can be just shipped and swapped without any security technician, any technician basically at this point. So yeah, like from this point, from the MCM part, just couple of connections required. And the same applies to DFSP, just initiating the registration, and local operator just responsible for physically connecting the device to the network. Yeah. Okay. So yeah, just wanted also to quickly show how this platform compares to other infrastructure options. It's not just in price, but how easy it is to run. So cloud systems can be easy to start, but they are hard to predict, and they need DevOps and stable internet connection. On-prem servers are powerful, but they take time to set up, cost a lot, and need local IT stuff. So the Edge platform offers a third option. It's fixed monthly cost, requires no on-site setup, and runs even without stable internet or power. In real world, in real deployments, this platform has shown at least 50% lower monthly costs comparing to cloud infrastructure, and often up to 70 lower than traditional on-prem servers that usually require IT and high capital investments. And for small DFSPs, that could make Mojaloop onboarding more possible and more sustainable. Yeah, so to finish, I want to connect everything back to the Mojaloop mission. So this platform was originally built for infrastructure limited environments. And it turns out these constraints closely match with what DFSPs still face when trying to join Mojaloop. It's already working in the field, and it aligns well with the Mojaloop goals like inclusion, decentralization, and making participation easier. It also fits with the tools like MCM and PM4ML, and could help make onboarding more repeatable, more secure, and less expensive. So a good next step could be just a small pilot, maybe 1 or 2 DFSPs to test how well this integrates with current workloads. From there, we can adjust the design, gather feedback, and see if it could become part of Mojaloop infrastructure guidance. So yeah, I'd welcome your thoughts and discussions on that, and thanks again for your time.
Thank you, Yev. That was very interesting. A lot of things to think about there. You know, of course, that we developed a simple Raspberry Pi solution for something like this, but it was nowhere near as robust as what you're suggesting here. And that to me is inherently very interesting. So I think I'd like to explore that further, but I'll perhaps leave it to James to ask any questions about that. But I did want to know whether you had considered perhaps also operating some, for a very small DFSP, some form of banking software there as well, so that this becomes all that they need. Something like Mythos, obviously being the prime candidate. Have you considered that or anything like that?
Yeah. I mean, just any pilot would help to just understand how everything is aligns.
So essentially, it could become a pre-packaged digital banking solution for a small DFSP.
Like,
very small.
The Mojaloop in the box that we were talking about lately. So an appliance that you can just, plugs right next to your core banking platform, and it automatically connects to the Mojaloop, basically. So
yeah, but I'm thinking of the context where there is no core banking platform to
connect. It can host anything, basically. It can host the core banking system itself. I mean, if they don't have anything they operate in Excel or just usual paper.
We both know there are small MFIs out there that are still working using Excel.
Yeah. So this can also work like that. So it can host all the infrastructure in this small box. So just delivered, configured for them, and they don't need anything basically. So they can use their usual, Excel, for example, if needed, actually. The exchange of the information between Excel and this box can be adjusted. Also, it's not a problem at all. It's just another integration layer along with all these core banking adapters, just working with Excel, that also can be applied to other similar DFSPs later. So it's like reusable. Like when you develop one adapter, the same adapter can be then applied to many other small DFSPs that operates like in similar fashion, like with the very simple Excel. So the only thing that requires is just the binding of some fields in Excel they use, and basically that's all. And this can also be even automated for them using some AI, just to understand how everything maps together. So even this can probably be a very small amount of manual work for a person who would develop this kind of mapping solution. So yeah.
Yeah, interesting. I see Nathan has his hand up. Nathan, would you like to ask a question?
Yes, please. Thank you for this interesting presentation. Yevhen, can you come back again on the diagram? I want the clarification there. Is it what we are implementing for Mojaloop, or is it what you have done before? I want to have this clarification first.
Yeah, so we had a very similar model here in Ukraine working. We have a local operator, basically, on site. So this stays the same, right? And there is the platform that usually we need to integrate with, right?
Okay.
So we don't develop a new UI for that. We just make this part of the existing system.
Okay, well, my question is regarding having the MCM aside the Skynet control plane. I know MCM is doing multiple things, and for example, creating DFSPs, maybe providing some connections for the reports. But I'm seeing here, could we just replace the Skynet control plane, replace the MCM with the Skynet control? Is not
not entirely. So the Skynet control plane is only managing the underlying platform. It's not managing the upper workloads like identity keys and other things. So MCM, the hub, basically is used for exchanging the Mojaloop keys. So all participants know that they are making transactions with the trustworthy party, right? So the MCM is sitting above, basically. It's so PM4ML workloads connect to the MCM in this case, and they operate with the MCM, with the hub, to make the software level of onboarding. Not onboarding, but the key exchange. But yeah, if MCM does only the exchange of the keys and nothing more, this control plane can freely do this as well, because it's already exchanged those keys with MCM.
Yes, because
it's just
maybe I will elaborate. We can deploy a switch with Helm without the MCM and connect DFSPs. So it means the switch can be deployed with the tools to connect to the DFSPs. But now we need those tools because we want to facilitate the exchange of keys and provisioning. We want to automate the provisioning. So this is why I'm thinking maybe there is a way to reduce the number of components in the flow, even to make the management easier, because the more tools we have, the harder the operation. So maybe I don't know if I understand well, or if someone can.
Yeah, I think I understand you.
Right.
So the thing is, the MCM here is well-known central hub. So even DFSPs that don't integrate don't follow this Skynex model can interoperate with MCM. So MCM acts as the common denominator here. So this Skynex control plane in this model, it drastically simplifies the onboarding of DFSPs that want to participate in this kind of model. And everything else, like the integration with MCM, can happen seamlessly, like under the hood, like the onboarding. So it means that, I mean, MCM should support all kind of DFSPs, right? So whether they use Mojaloop APIs, I don't know. So yeah, it's interesting. It's an interesting question, because if there are deployments that already have PM4ML installed, and if we are talking about the key exchange only, PM4ML technically can connect to the control plane just to get the keys of other participants, but it means that other participants should also, like existing PM4MLs should also publish their keys to this control plane. So it's about like, who is the central role, like who is the central hub here, right? And it's just like the decision that can be made like at any time. So it's not critical one.
Okay, thank you very
Can
much.
it can work in either ways.
Okay.
Yeah, thank you, Yev. Where are these devices manufactured, and how many users do you have of them?
So we have around 500 or 400 of active deployments.
Right.
In Ukraine.
Yeah.
They are distributed like all over the places, and like usually, like for example, in retail, they were used like before the war started. They were used first in retail industries for supporting their critical services, like post terminals, because this is also has like this system also, like it's a broader system. So this is just
Yeah.
a smaller part of it I'm presenting.
Yeah. I get
Yeah.
it.
So the broader also has this lockdown POS tablets that customers can operate at point of sale, and can like run kiosks and self-management, services. So when the war started, the telco integrators were started to search for an option to have the caching infrastructure backed by some low power systems, so that they can support running everything with just uninterruptible power supplies, because
Right.
existing systems were quite hungry in that, and they could not just survive even an hour.
Right.
And so we just decided to provide them, a bunch of these setups, because we had some stocks already, And yeah, so they were operating with these setups for 2 years already, with successfully. So yeah, and this model like proves really that it can survive all these harsh conditions that we see in Ukraine right now. So
Yeah.
yeah, like the devices, yeah.
So where do you source the devices from? Do you make them
The
yourself,
devices are
or?
sourced from different vendors. They are mostly Taiwan's,
Right.
Chinese, Koreans, like, but yeah, it's like the devices like we chose them much more earlier. It was like probably 5 or 7 years ago. It's just a specific system on chip platform that delivers everything we needed at that point. With the secure boots, the secure storage, the low power consumption, the availability of manufacturers that can support.
Right.
Because so.
We're just about out of time. To me, this has been really interesting. Does anyone have any final questions before we close today?
Just on any next steps that are planned, or thinking about what would you like to do next year? I guess I know you've mentioned looking for some kind of trial or pilot for trying to find some friendly people to test this out. If anybody on the call would like to test this out, I suspect it's no cost to themselves. Am I right, Yev?
Yep.
Yeah.
And yeah, please, let's keep the conversation going.
Yeah. And if anyone from the GTM team on this call, if they see likely candidates for trying this out, we'd welcome you with open arms. So yeah. Thank you, James. If that's all, thank you everyone for joining today. If you have any more comments, then please, you can direct it to me or directly to Yav. We're both on the Slack, the Mojaloop Slack. So thanks everyone, and see you all hopefully on Thursday, when I hope you'll join us, because we have another session, this one led by Dave Birch, an old colleague of mine and a financial sector strategist. So yeah, that should be a good session as well. So please come along to that. Okay, thank you everyone, and goodbye for now.
Thanks
very much. Bye.
Thank you. Bye.
Thank you. Bye.